Next part of the chapter, Vectors, Part 1b, Introduction. We're going to look into more of the column vectors for vector. Now, column vectors are written in the form x, y, where x is the horizontal component and y is the vertical component. X means going to the left or right direction, and y means going in the up or down direction. So given the following vectors down here seen in this diagram, we counted them on square grids, something that looks like the axis grids. And for example, I were to have the vector AB. To start with A will move in the horizontal direction of 2 squares. Hence, the x value is 2. And then it will move in the vertical upward direction of 3 squares to end at the point B. So B will have a y-axis of 3 units. In this case, what will be B to A? If it's B to A, AB and BA are the same vectors, but in the opposite direction. So recall that if I have an opposite direction, it will be negative of 2, 3, which means I will get the column vector negative 2, negative 3. Now give it a try. What is CD? So for example, C will to start from here, and I move in the x-axis direction first. So that will be 1 unit on the x-axis direction. Now I'm going to move downwards to the point D by 4 units. How do I indicate moving downwards by 4 units? That means I will get a vector, the number for the y, to be negative 4. And similarly, what is DC? I believe you can find the answer. We would like to try the questions on your own first before checking the answers. Taking a look at part G, C is this vector where I move horizontally 3 units. But I do not go up, neither did I go down. So what am I going to put for the y value? In this case, it will be 0. What about the vector D? Vector D starts from here, but neither does it go left, did it go right? So what should I put for my x value? So in this case, it will be 0. But then it moved downwards. So I will have negative 5. Let's complete the rest of the questions. Have you gotten the answer? Now express each of the following as a column vector. Now I would like you to spend some time to try out the different questions on your own first before checking through the answers. Okay, so please try the following question. Have you gotten your answer? Let's try to do some calculations with column vectors. Next part of the chapter. Question number 3. Given that the vector AB is 1, -1, 2, okay, and C is the vector 3, -4, express each of the following as a column vector. BA and AB are negative vectors. They are going in the opposite direction. Hence, BA will be 1, -2. What about C and -C? They are also going in the opposite direction, so they are negative of each other. So that means this will be 3, -3, 4. Have you gotten the answer? Let's move on to other types of questions. Question 4. D to E is given to be 2, -3, E to F, and F to G. Now what we are going to find the following column vector. I'm going to find G to F. Out of these 3 vectors, which of them has anything related to G and F? Now I know this is FG. So if I go from G to F, I'm going in the opposite direction. So I will have a negative of the vector, and the answer will be -1, 0. Next, let's find FE. FE is the same over here. It's going in the opposite direction. So we will have 3, 4. What about ED? This is quite easy too. E to D is in the opposite direction. So we get -2, 3. Have you gotten the answer? Now we have come to the end of this first part of the chapter on introduction. Let's recall some of the skills that we have learned for today's lesson. Number 1, we learned how to do vector representation in terms of writing a vector from the starting point to the ending point with an arrow on top. So it's vector, for example, AB. Or we can label vectors using small letters with roller skates at the bottom to indicate that it's a vector. Or if it's in printed format, it will be a different font with a bold to represent a vector. Magnitude of a vector, we have absolute value of AB, for example. Now this is actually the length of the magnitude, is the length of a vector. And what we can use to do, we can use the Pythagoras theorem to find out its length or its magnitude. Now equal vectors, we see these equal vectors in most of them are in, for example, parallelograms or even a hexagon question. Now what are the conditions for us to have equal vectors? 2 conditions. Number 1, they must have the same magnitude. And number 2, they must go in the same direction so that they will be equal vectors. Then what exactly is negative vectors? Negative vectors are vectors with the same magnitude, but they are in the opposite direction. We also learned in part A the zero vector. Zero vector can be represented by the letter 0 with skates below. Now, zero vector doesn't mean it's just no vector at all. It just means that the resultant value, okay, will be the vector 0, 0. Meaning, I started at point A, I traveled somewhere else, and I returned to point A again. So that's why this is called the zero vector. In part B of our notes, we learned this thing called the column vector. Now, column vector can be used to represent the vectors in the form of a column. So now a column have 2 of the values. What are the two values? X and Y, where X meaning it's moving in the x-axis direction. If it's moving to the right, it's positive. If it's moving to the left, it will be negative. And the Y value is going in the y-axis direction. If it's going in the upwards direction, the number is positive. If it's going in the downwards direction, the number will be negative. Now, we have come to this part of the end, to this part of the chapter. Up next, the next few lessons, we're going to do the triangle addition law and addition and subtraction of vectors. Stay tuned for more action.